Hello all. In today's lecture, we'll be studying about Karnaugh Map or K-Map. What do you mean by Karnaugh Map? Karnaugh Map is nothing but a graphical representation of a truth table. Why we have to study, why we are going for Karnaugh Map? It is mainly used for solving a Boolean function to get a simplified Boolean expression. Based on the number of variables in your Boolean function, we'll be classifying the K-map into different categories. Like it can be classified as 2-variable Karnaugh Map, 3-variable Karnaugh Map, 4-variable Karnaugh Map, and 5-variable Karnaugh Map. We'll be studying about every single block in detail. Let's start with 2-variable. 2-variable meaning, what does it mean? Say for example, f of a comma b. Right? These are the 2 variables. Fine. A and B are the 2 variables. If in your question, if it is given like f of a comma b is equal to some values, then based on these 2 numbers, you can identify that there are only 2 variables, so we'll be using Karnaugh Map. Fine. Now, so for 2 variable, how many combinations are possible? That is based on 2 power n. Fine. Say for example, there is only 1 variable. So, based on this formula, 2 power 1, it is 2. So, how many combinations are possible? It is either 0 or 1. Got it? 0 is represented with a complemented form and 1 is represented with an actual variable. So, if there is only 1 variable, then you have 2 combinations for it. Understood? Whether to take it as a complemented form or actual form, that is based on whether you will be following SOP or POS. Fine, that we will deal it when we are solving the problem. Now, say for if there are 2 variables, so how many combinations are possible? 2 power 2, it is 4. So what are the combinations? It is 0, 0, 0, 1, 1, 0 and 1, 1. These are the 4 different combinations that you can get for a 2 variable. Clear? In a similar way, for A, B, C, I have 3 variables. So how many combinations are possible here? 2 power 3, that is 8. So what are the combinations? We'll be getting 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So these are the combinations that I'll be getting for 3 variables. Understood? If there are 4 variables, suppose there are 4 variables A, B, C and D. How many combinations are possible? 2 power 4, that is 16. That is from 0 to 15. Is that clear? Now, let's see how to represent these combinations in a graphical format. For a 2 variable, let's take 2 variable. How do you represent 2 variable? Let's assume the 2 variables as A and B. Not necessary, it has to be only A and B all the time. It can be any variable. For example, I'm taking A and B here. Fine. Now, let the 2 variables be A and B here. So, on the left hand side, I've got only 1 variable. Right? So, 1 variable, how many combinations are possible? There are 2 combinations. What are the combinations? It is 0 and 1. In a similar way, on the top, I have only 1 variable, which is B. So, how many combinations are possible for this? It is 0 and 1. Got it? Now, for 2 variable, how will you get all the 4 combinations? This is nothing but 0, 0. This is nothing but, how can you write it? This is something like 0 into 0, it is 0, 0. 0 into 1, it is 0, 1. 1 into 0, it is 1, 0. And then 1 into 1, it is 1, 1. Right? This is how you will be getting all the 4 combinations. What are the equivalent decimal number for these combinations? 0, 0, it is 0. 0, 1, equivalent decimal, it is 1. 1, 0, equivalent decimal, it is 2. And 1, 1, the decimal number, it is 3. Understood how to write the equivalent decimal number? So, I am just mentioning the same numbers here. Understood? Now, in a similar way, how will you represent a 3 variable mapping? Let me assume let the 3 variables be f of A, B and C. Clear? How do you represent it? For 3 variable mapping, how many combinations are possible? It is 8. That is, I should have 8 boxes in that. 0, 1, 2, 3, 4, 5, 6 and 7. From 0 to 7 if I calculate, it is altogether 8 boxes. Right? Give me the decimal number for this. It is 0, this is 1, this is 2, this is 3, This is 4, 5, 6 and 7. Clear? Now I have to represent those numbers inside those boxes. How to represent? Let me take, this is B and this is A and BC. On the left hand side, I've got only one variable. So how many combinations are possible? For single variable, I will have two combinations. So 0 and 1. Understood? For BC, there are two variables here. For two variables, how many combinations are possible? Four combinations. So how do you write the combinations? It is 0, 0, 0, 1, 1, 0 and 1, 1. You can ask me, why did I write 1, 0 here and 1, 1 here? For that, let me explain. Every single combination, assume that as a single state. Fine. Now, when I move from one state to another state, that is, this is one particular state and this is one particular state. When I move from one state to another state, there should be only one bit change that is happening at a time. What do you mean by one bit change? Only one number can change from, only one particular bit can change from one number to another number. That is, 0 can change to 1 or 1 can change to 0. At a time, only one bit change can take place. Right? Now, when I'm moving from this state to this state, first number it is same, no change. Only the second bit is changing. That is, there is only one bit change that is happening. So this combination is valid. That is why after 0, 0, I have put 0. This combination I have put. Fine. Now, assume I am writing 1, 0 here. Check on the bit change. The first bit is changing. So one bit change is already done. Check on the second number. Here again, 1 is changing to 0. So there is 2 bit change that is happening. But always there is a condition like when you're moving from one state to another state, only one bit change is allowed. 2 bit change is not allowed. That is the reason we are not writing 1, 0. Instead, what is the other number left? That is 1, 1. So I'm going to try with 1, 1. Now, on comparing between these two states, the first bit, here 0 is changing to 1. So 1 bit change has already happened now. Check on the second digit. Here it is 1 and 1. So the second bit is same. So when I'm moving from this state to this state, only the first bit is changing. That is, there is only one bit change that is happening. Right? So this combination is valid. That is why after 0, 1, I put 1, 1. Clear? Now, what is the number that is left? It is 1, 0. Let's check. We are getting one bit change when I'm moving from this state to this state. Here, check on the bits. The first bit is same. Only the second bit is changing. So when I'm moving from one state to another state, there is only one bit change that is allowed, and I'm getting only one bit change that is happening. Right? So this movement is again valid. That is the reason I put 1, 0 here and 1, 1 here. Is that clear? Now, how do you write the numbers? How do you find the decimal numbers inside? Compare the numbers. 0 with 0, 0. 0 with 0, 0. The first digit, it is A, B, C. Fine. Again, I am checking 0 with 0, 1. 0 with 0, 1. Clear? Now, I am checking 0 with 1, 1. Again, I am checking 0 with these two numbers. That is 1, 0. Clear? Let me fill it up. And here it is 1 with 0, 0. 1 with 0, 0. 1 with 0, 1. 1 with 1, 1, 1. 1 with 1 and 1, 0. Got it? Now, write the equivalent decimal number for every single combination. For 0, 0, 0, what is the equivalent decimal number? Check here and tell me. What is the equivalent decimal number for 0, 0, 0? It is 0. Right? Now, what is the equivalent decimal number for 0, 0, 1? It is 1. For 0, 1, 1, it is 3. So, I'll be mentioning 3 here. For 0, 1, 0, it is 0, 1, 0, it is 2. 1, 0, 0, it is 4. 1, 0, 1, it is 5. 1, 1, 1, all 3 ones are, it is number 7, and 1, 1, 0, it is number 6. Understood how to write the decimal number inside the box? So I'm just giving the same numbers. It is 0, 1, 2, 3, 4, 5, 6 and 7. Understood how to write the numbers for a 3 variable mapping? Similarly, let's see how we are going to write for 4 variable mapping. Let the terms be f of a comma b comma c comma d. Clear? Now, let me erase this. For 4 variable in the sense a is one variable, b is another variable, c is another variable, and d is another variable. You have 4 variables here. So how do you do the map graph here? How do you represent it in the graphical format? It is like this. Clear? Now, on your left hand side, you have 2 variables. So for 2 variable, how many combinations are possible? We got 4 combinations. And how to write the combination? You very well know. I'm just repeating it. 0, 0. Next number it is 0, 1. Then it is 1, 1. And then it is 1, 0. Right? Similar way on the top again, there is 2 variable. So for 2 variable, how many combinations you have? It is 0, 0, 0, 1, 1, 1 and 1, 0. The 4 combinations. Clear? Now, how you found out the decimal numbers? In a similar way, you have to find out the decimal number and write for this as well. Clear? Take out the combinations now. For 4 variable mapping, how many combinations you got? 16. The combination starts from 0 to 15. Right? So what are the combinations? It is 0, 0, 0, 0. This corresponds to 0. 0, 0, 0, 1 corresponds to 1. 0, 0, 1, 0 corresponds to 2. 0, 0, 1, 1 corresponds to 3. 0, 1, 0, 0 corresponds to 4. 0, 1, 0, 1 corresponds to 5. 0, 1, 1, 0 corresponds to 6. 0, 1, 1, 1 corresponds to 7. Clear? And 1, 0, 0, 0 corresponds to 8. 1, 0, 0, 1 corresponds to 9. 1, 0, 1, 0 corresponds to 10. 1, 0, 1, 1 corresponds to 11. 1, 1, 0, 0 corresponds to 12. 1, 1, 0, 1 corresponds to 13. 1, 1, 1, 0 corresponds to 14. And 1, 1, 1, 1 corresponds to 15. Is that clear? Now, you have to fill in the numbers inside. How do you fill in? 0, 0, 0, 0. Let me draw it here so that it will be easy for you to understand. Now, take the numbers. AB, it is 0, 0. CD, it is 0, 0. Right? Similar way. AB, compare it with these two numbers. It is 0, 0, 0, 1. AB is 0, 0 and CD is 1, 1. AB is 0, 0. CD is 1, 0. Clear? In a similar way. AB is 0, 1. CD is 0, 0. AB is 0, 1. CD is 0, 1. AB is 0, 1. CD is 1, 1. AB is 0, 1 and CD is 1, 0. Clear? Now, AB is 1, 1. CD is 0, 0. AB is 1, 1. CD is 0, 1. AB is 1, 1. CD is 1, 1. AB is 1, 1. CD is 1, 0. Is that clear? Now, the last column, it is 1, 0, 0, 0. 1, 0 for AB and 0, 1 for CD. 1, 0 for AB and 1, 1 for CD. 1, 0 and here again CD is again 1, 0. Got it? Now, the corresponding decimal number you have to write here. Give me the decimal numbers. 0, 0, 0, 0 corresponds to 0. 0, 0, 0, 1 corresponds to 1. 0, 0, 1, 1 corresponds to 3. 0, 0, 1, 0 corresponds to 2. Understood? In a similar way. 0, 1, 0, 0. 0, 1, 0, 0 corresponds to 4. 0, 1, 0, 1 corresponds to 5. 0, 1, 1, 1 corresponds to number 7 and 0, 1, 1, 0. 0, 1, 1, 0 corresponds to number 6. Is that clear? Now, 1, 1, 0, 0. 1, 1, 0, 0 corresponds to 12. 1, 1, 0, 1 corresponds to 13. all 4 ones corresponds to 15. 1110 corresponds to 14. Is that clear? Here 1 0 0 corresponds to 8. 1001 corresponds to the number 9. 1011 corresponds to number 11. 1010 corresponds to number 10. Is that clear how to write the numbers, decimal numbers? Now I'm just going to represent these numbers back in the boxes. So how do you write? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This is how you will be representing. Is it clear? This is how you will be representing a 4 variable map. Now coming to 5 variable map. How do you represent a 5 variable map? For 5 variable map, how many combinations you have? 2 power 5, that is equal to 32, right? Now, suppose my variables are A, B, C, D and E. Fine. If these are my variables, then the first column corresponds to E bar and the second column corresponds to E. Clear? And how do you write the decimal numbers? The combinations are the same. The 0, 0, 0, 1, 1, 1 and 1, 0. Here again it is 0, 0, 0, 1, 1, 1, 1, 0. Here again 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. Clear? Now you have to write the decimal part. How do you write the decimal part? It is same as 4 variable mapping. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Clear? But you know 2 power 5. For 5 variable mapping, you have 32 combination, right? So after 15, you have to continue the numbers here in the next box. That is 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 and 31. That is starting from 0 to 31. Clear? This is how you will be representing a 5 variable map. Clear? Now, your first step was to identify how many variables it is being given to you in the question. Based on the number of variables, you have to choose which K-map you want to use for solving the equation. Your second step is positioning the values inside a K-map. How do you position the values inside a K-map? Now, your next step is positioning the values in the K-map. How do you position your values? Say for example, f of a, b, c, d. My numbers are 0, 2, 4, 6, 8, 10, 12 and 14. Fine. If a question is being given to me like this, say for example, f of a, b, c, d and these are my numbers. Fine. Your first step is to check what symbol you have got here. If you have got a sigma, it means all the numbers that you have it here has to be represented with a number 1 inside your K-map. Fine. Sigma meaning SOP. If it is SOP, if it is sigma, all the numbers that are given to you in your question, you have to mention them with 1. Clear? Suppose if you have a pi in the place of sigma, then it means it is a POS. So for a POS, all the numbers that are given inside your bracket has to be represented with a 0. Clear? Let's solve the problem for POS and SOP. For now, let's take SOP alone. Clear? Sigma meaning SOP. Fine. Now, how many variables are here? There are 4 variables. A, B, C and D. There are 4 variables. So which K-map you will be choosing? You will be choosing 4 variable K-map because you have got 4 variables here. Fine. Now, whatever number that has been given to you inside your bracket, if it is sigma, as said before, if it is sigma here, meaning it is SOP. So whatever number has been given to you in your bracket, in that corresponding box, in the K-map, you have to mention a 1. Clear? Now, what is the first number? It is 0. So mention a 1. Second number, it is 2. Identify where the number 2 is. 2, it is here. All these are decimal numbers. So you have to check for the decimal number inside the box. And in that corresponding position, wherever this number is there, that corresponding box you have to put a 1. Is that clear? Now what is the next number? It is 4. Against 4, I'll put a 1. 6. Where is 6? 6 is here. So against 6, I'll put a 1. Your next number is 8. So against 8, I'll put a 1. Next number, it is 10. So against 10, I'll put a 1. Clear? Next number, it is 12. So against 12, I'll put a 1. Next number, it is 14. So against 14, I'll put a 1. Is that clear? How to represent, how to position these numbers inside the K-map? Your first step was to identify which K-map I have to choose for solving my problem. Clear? And your second step is positioning the values inside the K-map based on whether it is an SOP or a POS. Clear? Fine. Let me give you another problem. F of A, B, C is equal to sigma of 0, 1, 2, 3, 5. Fine. Now, how many variables are here? There are 3 variables, A, B and C are the 3 variables. So which K-map I'll be choosing? I'll be choosing a 3 variable K-map. Clear? Now, second step is identify whether it is an SOP or a POS. How do you identify? Based on this sigma. If it is sigma, it means it is SOP. If it is pi, it means it is POS. Now here sigma is given, so it is SOP. If it is SOP, then what is the next step? Whatever number is given to you in your question, those numbers you have to represent them inside your K-map with a 1. Clear? Now what are the numbers? It is 0, 1, 2, 3 and 5. So against 0, I'll put a 1. My next number, it is 1. So against 1, I'll put a 1. Next number, it is 2. So against 2, I'll put a 1. Next number, it is 3. So against 3, I'll put a 1. My last number, it is 5. So against 5, I'll put a 1. Is that clear? Now, let's solve one more problem. F of A comma B is equal to pi of 0. Now, how many variables are here? 2 variables, right? So which Karnaugh map I'll be choosing? I'll be choosing a 2 variable Karnaugh map. Let me write this here. Fine. I'll be choosing a 2 variable Karnaugh map because in the question again I have only 2 variables. Clear? What is my second step? I have to identify what is this symbol here. And based on it, I'll find out whether it is an SOP or a POS. Now, here it is pi. If it is pi, then this is a POS, correct. If pi is mentioned, then it means it is a POS. If it is a POS, whatever number has been given here, you have to mention them using a 0. Those numbers are to be positioned inside the corresponding K-map using a number 0. Clear? Now, what are the numbers? It is 0. So, against 0, I'll put a 0. The second number, it is 1. So, against 1, I'll put a 0. Last number, it is 2. So, against 2, I'll put a 0. Clear? If it is sigma, then it is SOP. So, all these numbers, I'll be positioning inside the K-map using the number 1. If it is POS, all the numbers that are given inside the bracket, those numbers I'll be positioning inside the K-map using a number 0. Clear? This is how you will be positioning the numbers inside the K-map. What was your first step? First step was, based on your question, you have to find out how many variable it is. So accordingly, you will be deciding which variable map I have to choose. Whether for 2 variable, 3 variable, 4 variable. Clear? Your second step is positioning the values inside the K-map based on whether it is SOP or POS. If it is SOP, you'll positioning them using the number 1. If it is POS, you'll position them using the number 0. Clear? The third step is mapping. While doing the mapping, there are certain set of rules that you'll have to follow. Mapping can always be done in horizontal or in vertical. Fine. Diagonal mapping is not allowed. Clear? Apart from this, mapping can be done only based on the 2 power n. A single digit mapping, single number can be mapped, or 2 power 1, that is a pair. 2 power 1, it is 2. A pairing can be done, 2 power 2, it is 4. That is a quad number can be mapped, or 2 power 3, it is 8, which is an octave. The octave grouping can be done, or 2 power 4, which is 16, the hexagon. Hexagon mapping can be done, or 2 power 5, which is 32. A 32 number grouping can be done. Fine. What do you mean by all this? Whenever I mention 32, meaning all the boxes, if they carry a 1, it means that the entire group can be taken as a single group. And then that is called a 32 mapping, group mapping. Let's say for 16. Fine. What do I mean by 16? How many boxes are here in this? For a 4 variable map, we have 16 boxes, right? So when I have a 1 in all the boxes, in that case, I'll include the entire box as a single term. And this is called a 16 group mapping. Fine. Always the priority has to go from bottom to up. This will be the top priority, this will be the next priority, this will be the next priority, and then it goes on. Fine. On the priority basis. If you don't find a 16 group mapping, only then go for 8 group mapping. If you don't find an octave mapping, only then go for quad. If you don't find a quad, only then go for a pair. And if you don't find any pair, then go for a single number mapping. Clear? Let me tell you how to do the mapping now. Let me erase this. When we have 1 in all the boxes, then all together you can group it as a single group. That is called a 16 group map. Your first priority has to be to check whether we have 1 in all the boxes. In case, if we don't have 1 in few boxes, randomly I am choosing. If you don't have 1 in all the boxes, then you cannot do this grouping. This grouping can't be done. Fine. In that case, we go for octave grouping. Fine. How do you do an octave? If you find octave meaning 8 numbers together. All the numbers has to be in sequence. Say for example, if you find 8 numbers in sequence like this, then these 8 can be grouped as a single octave. Fine. This is like 8 in sequence, and this is horizontal grouping. Fine. In a similar way, if you have 8 ones in sequence on the vertical, you can group them as well as a single octave. You can group this as a single octave. This is called vertical. This vertical can be on the left or can be on the right. In a similar way, the horizontal can be the bottom or on the up. It can be any way. The other combination is you can group this as well. This is again called an octave. When this is something like when you are folding, consider this as a single sheet of a paper. Fine. When you fold it, this lower and the upper part will come together. So that again can become an octave. Clear? This is like folding. So this again is a valid way of considering it as an octave. The other combination is like this. This is folding horizontally and this is folding vertical. Got it? These are the different combinations through which we can consider them as an octave. Wherever you have one like if that is following this particular pattern, those patterns we can group them together in the octave. By chance, if you don't have 8 consecutive ones like this, if you have some numbers vacant and it is not contributing to an octave, then you go for the quad. Let's see how to go for the quad now. And taking the same 4 variable mapping. This is a quad, valid quad. When I have all ones in sequence, this again is a quad. Fine. When I have all ones on the vertical, this again can be grouped as a quad. These two again can be grouped as a quad because when I fold it vertically, these two come together, right? This again can be considered as a quad. In a similar way, if I have ones like this, these two again, if I have these two again, while folding these two again can become a quad. The other possibility is if I have ones in all the corners. This is something like I am folding the paper vertically and then I am folding it horizontally. Fine. When I fold it horizontally and then vertically, or vertically and then horizontally, either way, when I fold it, then all the corners come together. So this again can become a quad. Understood? These are the different possible combinations for a quad. How you can group them. Fine. This 4 numbers, not necessary it has to be here. If you have ones like this again, you can group it. You can group it. Overlapping is allowed. Now, if you are not able to go for a quad, if you don't find any grouping that can be done using a quad, only then go for a pair. Let's see how to do a pair also. Let's go with how to do a pair. For that, let me take a 3 variable map so that you'll understand it better. Fine. For a pair meaning 2 numbers together. If the numbers are like this, you can group them together. Fine. Or if you found numbers like this, you can group them together, right? You cannot group all these 3 numbers together because it doesn't follow this criteria. It should always be in the power of n. 3 doesn't come in power of n, right? What are the numbers you can get? Either you can pair a 1, 2, 4, 8, 16 and 32. Fine. That is the reason we have paired them separately. Got it? And if you have 1 in the corners, then you can pair them like this. Understood how to do the pairing? Pairing, either it can be done horizontally or vertical. This is something, the corners are nothing like folding. Got it? I'll tell you an example of how the diagonal can't be done. Let me take the same 3 variable mapping. Fine. If I have numbers like 1 is here and 1 is here. Now, 2 numbers are there, but they are not in sequence, so I cannot go for a pair. So pair combination is not possible here. In that case, I have to go only for 1. Fine. In that case, I will be doing a single group mapping. Got it? Now, by chance, if I have a 1 here, here again, I cannot group these 2 numbers like this. This is not allowed. Diagonal grouping is not allowed. Diagonal grouping is not allowed. But if a number was here, let me take the same 3 variable mapping. If my number was here, I can group it. If my number was adjacent to it, I can group it. But my number is like this. 1 and 1. These 2 numbers cannot be grouped. Understood? Diagonal. This is called diagonal. This diagonal grouping is not allowed, not just in pair, in any of these combinations. In all the combination grouping method, you can either go for horizontal or vertical or folding. Folding is again horizontal and vertical, right? But diagonal is not allowed in mapping. Fine. I hope you are clear with when to go for single variable mapping, when to go for 2 variable mapping. Always check the first priority has to be 16. You have to check whether you have 1 in all the boxes. If you have 1 in all the boxes, then that should be considered as a single group. If you don't find 1 in all the boxes, if you have some vacant spaces, few of the boxes, then see if you can do an octet. If you are not able to get an octet, then go for quad. If you don't get a quad, then go for pair, and if pair is again not possible, only then go for single digit number. Is that clear? The priority has to be from bottom to up.
first priority should always be to 16, then to 8, then 4, then 2, or if nothing is possible, then go for 1. The ultimate aim is you shouldn't leave any numbers. Wherever if you found 1, whatever minterm that has been given to you in your question, it should be mapped in some way or the other. Fine, you shouldn't leave any single term. Now, you have understood how to do the mapping also. Fine. Now, based on the mapping, you have to reduce the equation. This mapping, it is mainly done, we are grouping it so that we are reducing the time taken for solving any Boolean equation. The reason for doing the mapping is only this. Now, we have grouped them. Based on the grouping, you have to find the expression. Let's see how to find the expression now. Your final step in any Karnaugh map is getting the simplified Boolean expression. How we will be getting the simplified expression? That is based on the mapping. Fine. Say, let's take an example of whatever numbers we have put for the 3 variable mapping. Now, tell me how we can do a grouping. These two numbers can be grouped. These two numbers can be grouped. Got it? I can do a mapping here as well, but it's already been grouped. If I do a mapping, it is like repetitively I am continuously doing it. So, I have taken only 2 groups. Got it? Now, how will you write the equation? F of a, b, c is equal to, now, a 0 corresponds to a bar. I told you in SOP, 0 corresponds to complement and 1 corresponds to the actual variable. Fine. In a similar way, POS in product of sum, 0 corresponds to actual variable and 1 corresponds to complemented variable. Clear? Now based on that, tell me. Let's solve for SOP first. 0 corresponds to complemented. Since A is here, all these two numbers corresponds to the variable, first variable, that is A. So 0 corresponds to A bar and 1 corresponds to A. Clear? Now, here B, C are the two variables on the top. So whatever combinations that I have here, that has to be represented based on these two variables alone. Fine? Here the first digit corresponds to the first variable and the second digit corresponds to the second variable. Got it? The first digit corresponds to B and the second digit corresponds to C. Now, if 0 is there, it is represented with a complement in SOP. We are solving only SOP right now. So, 0 corresponds to B bar. Since 0 corresponds, the first digit corresponds to the first variable. Now, 0, the second digit corresponds to the second variable. Since it is 0, I put a C bar. So, let's take the second state. It is B bar and C. First digit corresponds to the first variable is B. And since you have to mention that in the form of a 0, so I have taken a complement of it. The second digit is the actual variable, which is C. Second digit is C and it is represented in actual variable, so I will be giving C. For the third, first digit is B and the second digit is C, since both are in the actual form. Now, for the fourth state, first digit corresponds to 1. What is the first digit here? That is B. So, B will be mentioned like that. And the second digit corresponds to 0. 0, it is C. The second digit is C. And you have to mention that in the complemented form. So, it is C bar. Understand? Fine. Now, this is how you give the variable name. Okay, let's do the same for all the variables so that it is easy for you to solve. Here, what is the variable on your left hand side? It is A. So, for 0, you can write it as A bar. And for A, 1 you can write it as A. Got it? And for B, the two combinations are 0 and 1. 0 will always get represented in, let's solve with SOP first and then let's move on with POS. Let me assume the 3 variables as fine. This is for SOP. We are solving only SOP right now. Fine. Now, B is represented as 0. So, you have to mention it as B bar, the complemented version of it. For if B is given as 1, it means you have to mention only the actual variable, that is B. Clear? Say, for 4 variable, give me for the 4 variable. Let me write it in. Give me the variables. Here on the left hand side I have A and B, meaning the first group corresponds to A and the second group corresponds to B. Got it? If 0 is there on the first group, then you have to mention it as complement of that variable. Clear? Here 0 is mentioned here, so it will be represented as A bar. And for second group it is B, so B is in 0. It should again be in complemented form. Take the second state. Here the first variable is 0, so it should be represented as A bar. The second variable it is 1, so it will be represented as B. Got it? Here it is A, B, and for this it is A and B bar. Clear? Let me write it here so that it will be easy for you to solve once. A bar, B, and this is A bar, B bar. Clear? In a similar way, here the first digit corresponds to C, all the first digit corresponds to C, and a second digit corresponds to D. So give me the terms. It is C bar, D bar, it is C bar, D, C, D, C and D bar. Clear? Now, based on this, we have to solve the equation. Every group corresponds to one minterm. Group in the sense this entire bubble. So how many minterms I'll be having it here? Minterms in the sense product terms. Fine. How many minterms we'll be having it here? We'll be having 2 minterms because there are 2 bubbles here. Fine. Sum of product meaning it is like you are going to sum up the product terms. Got it? Sum of product meaning it is the sum of the product terms. That is why the term called SOP, which is sum of product terms. Fine. Now these product terms are called the minterms. So we have 2 minterms here. Fine. And every minterm corresponds to one bubble. Every single bubble will be having one minterm. Fine. For this particular bubble, let's take this bubble now. So you have to check on the horizontal as well as on the vertical side, which is common. Only the common terms you are going to include inside the bubble.
Now, which is the common term for this bubble in the vertical side? For this one, which is inside the bubble, A bar is common, right? And again, for this one, which is again inside the bubble, for that again, A bar is common. Whichever is common term on the vertical as well as on the horizontal, we have to take that. For this bubble, on the vertical side, A bar is common. So I'll write A bar. Fine. For the same bubble, check on the horizontal as well. Now, here, compare B bar, C bar, B bar, C. Because these two terms are corresponding to this one and this one inside the bubble. Right? Now, check for the first term. Here it is B bar, here again it is B bar, meaning both the place B bar is common. Right? So let me write B bar. Check for the second term. Here it is C bar and here it is C. Both are differing. C and C bar is not the same. Common meaning both has to be either the actual term, that is either both the numbers for the bubble can be BB or it can be B bar or CC or C bar for this particular bubble I'm talking. Clear? Here when we compare for both the terms on the horizontal part, it is B bar is common here. For this term again B bar is common. Right? So we will be taking only B bar outside. For the second term, check for the second term. Here it is C bar and here it is C. That's why we are not going to include that. Both are different. Clear? In a similar way, every bubble corresponds to one minterm. Understood? Now we have got 2 bubbles. So both the bubbles we have to write. We have to write the expression for both the bubbles. For the first bubble we have written, we are writing the sum of product terms. Sum of product terms meaning what? Sum of the product terms, where each product term corresponds to one minterm. We have written one minterm here. The other minterm we have to write. Check for the other minterm. Let's take this bubble now. For this bubble, check on the vertical part which is common. For both the ones which is inside the bubble, A is common. When you check for one, A is common for this one and A is common for this one as well, right? So we will write A. Check on the horizontal part. Check for these 2 elements. Which is common here? Check the first element. Both the places B is common. Right? So let me write B. Check for the second term now. Here it is C and here it is C bar. Both are differing. So I cannot include that. Whichever variable is common to both the terms inside the bubble, only that particular variable I'm going to take. Clear? And that we will be one variable is for the horizontal part and one variable is for the vertical part. We have to include both the variables and then put them as a product term, and every bubble we have to sum it. The expression for every bubble we will be summing it up. Understood? And this is the final equation for this particular K-map. Is that clear how to write? Fine. Now let's write the equation for this. Here, how can you do the mapping? These two numbers, there is no 4 variable mapping done here because there is one space which is vacant. So 4 variable mapping cannot be done. So what is the next mapping that we can see for? It is 2 variable mapping. So these two terms I have taken and these two terms I'll be taking. I said overlapping is allowed. Fine. Now write the equation for this. F of a comma b is equal to, now let's take this bubble. For this bubble on the vertical side, which is common, a bar. A bar is common to this one as well as to this one inside the bubble, right? So I'll be taking a bar. For these two terms on the horizontal part, which is common, here it is b bar, here it is b. Both are varying, so I cannot write. Only the common terms you have to write. Fine. For this bubble, check on the vertical part, which is common. For this particular one, it is a bar, and for this particular one, it is a. Both are different, so I cannot write anything. Now, for these two variables, which is common on the horizontal part, it is b. Correct? Understood how to write the equation? Let's find out the equation for this as well. Say, let me give the variables like, let me do some octave for you. Fine. If this is the case, what will be the equation for this? What are the function variables? It is a, b, c and d. Now for this particular octave bubble, check on the vertical part which is common. Here, let's take the first term alone. I'm taking only the first term now. Clear? For the first term, here it is a bar, here it is a bar, both are matching. But when it is coming to here, it has become a. So it is differing here. So we cannot take the first term. Understood? Now, let's go with the second term. Here it is b bar, here it is b. Initially itself it is differing. So I cannot take both. Understood? Now, let's check on the horizontal part, which is common here. Here the first term, it is c bar and c. Both are varying, so I cannot take it. Understood? Check on the second term. Here it is d, here it is d. Take d is common on the horizontal part. So I'll take d. Is it clear? Or whatever we have done now, it is all based on SOP. Now let's try to do the mapping for POS as well. Let me take the same 4 variable mapping. Fine? For the same equation we'll take. In POS, what do you mean by POS? POS meaning product of sum terms. These sum terms are also called as max term. Every single bubble is going to be a max term. And all the bubbles you're going to do a product. Now, let's see how to derive the equation for the same octave. Fine. Before that, how will you write this? I told you all the terms are max terms. Whereas in POS, you represented all the terms as product term. Right? Here, because they were all minterms. Minterms, I told you, they were all product terms. Whereas in case of POS, all the terms are max terms. So you have to represent them as a sum. And in POS, 1 is represented as a bar and 0 is represented as an actual bit. Clear? Based on this concept, can you give me the equation for this? It is a plus b, because 0 is represented with actual variable. All the first term corresponds to a and all the second term corresponds to b. And every term you are going to represent them using a max term. Fine. Now, for this, it is a plus b bar. Why b bar? Because 1 is represented with a complement. Here 1 corresponds to the second term, that's why I am writing b bar. Fine. For this, for 1 1, it is a bar plus b bar. For 1 0, it is a bar plus b. In a similar way, can you give me the expression for this? It is c plus d, c plus d bar, c bar plus d bar, c bar plus d. And in POS, you know, all the terms, you are going to represent them using zeros. Fine. How do you position the elements in SOP? We position them using 1. Whereas in case of POS, we'll be positioning them using 0. Clear? Now, find out the equation for this f of A, B, C, D, which is common on the vertical part. Here, when you take the elements, when I'm taking the first column, it is A, it is common, but when it is coming here, it is coming to A bar. So I cannot take the first variable. Check on the second variable. Here it is B, here it is B bar. It is initially itself it's varying, so I cannot take it. Okay, now let's check on the horizontal part. Check on the first variable. Here it is C, here it is C bar. Both are varying, so I cannot take it. Check on the second term. Here it is D, here it is, here it is D bar, here again it is D bar. So only D bar is common. So my final expression will be like this. Understood? Let's solve some more problems on POS. Let me solve a 3 variable mapping for you so that it will be easy for you to understand better. Let me take something like, let's take the same example, the one that we solved previously. Fine? Fine? Now, give me the equation. Mapping is going to be the same. There is no change in the mapping. The two things that is going to differ with POS and SOP is, in SOP we will be positioning all the elements with 1, and in POS we will be positioning all the elements with 0. Fine, that is one thing. The second thing is, in SOP all the terms will be in product terms, that is min term, whereas in case of, and in POS all the terms will be in max term, that is in sum term. The other thing, like how to do the mapping and then checking for the expression for that particular bubble by checking on the horizontal and vertical, everything it is going to be the same. Only two things are going to differ. One, it is zeros that you have to position, and the second thing is, instead of min terms you'll be representing here with a max term. Is that clear? Fine. Give me the expression for this. Now let's take this particular bubble. For this bubble, which is common here, it is A plus. Now check on the horizontal part, which is common. I'm taking the first element. Here it is B, here it is B. So B is common, so I'll write B. Now check on the second term. Here it is C, here it is C bar. It is differing, so I cannot write it. Only the common term you will be taking. Understood? A plus B dot. Because POS is product of the sum terms. Clear? Now let's take this bubble. For this bubble, which is common here, it is A bar plus. Check on the vertical horizontal part, which is common here. It is the first element, it is B bar, B bar. So I'll write B bar. The second element, it is C bar and C, that is going to differ. Clear? Understood? This is how you'll be writing the expression for POS and for SOP. I hope you're clear with the concept of K-map. Let's sum it up. What did we see? We saw what a K-map is, what are the different types of K-map. Based on the variables that we have in the function, we'll be classifying them as 2 variable, 3 variable, 4 variable and 5 variable, and how to graphically represent each variable mapping. How to graphically represent a 2 variable, how to represent a 3 variable, 4 variable, and the second step is how to position the elements inside the K-map. Fine. And the third step is mapping. What are the different types of mapping, like hexagon, and then quad mapping, octave mapping, pair mapping, and then a single element mapping. Clear? After doing the mapping, from the map bubble, how to write the expression. How to write the expression for POS as well as for SOP. We have seen both. In the next class, we'll be studying about don't care conditions. Clear? I hope you're clear with the concept. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.